vertical curve? Right, it's parabolic in shape, and you notice here, take a look at this. This is all, where it has all these little hatch marks, that's what the ground surface looks like. Okay, you see all those hatch marks, you see how it's kind of squiggly? And then the civil engineers came through and designed the vertical curve, look up here, to go this way. So what is this right here, cut or a fill? Cut, here, here, cut. Okay, yeah, okay. Okay, so let's just go through. It's a lot of number crunching, but it's a lot shorter, and there are two problem areas that I find that students make mistakes, and I'll point those out, but I think it's not that bad. Okay, you ready? Everybody ready? You ready? You ready?
Ready.
All right. So, I'm on page 77. Okay, are you looking up here? Let's see, I think I got this guy to work, right? So, this is what the ground looks like. G1 represents the grade of the left side of the, just way ground surface is. And G2 represents the grade of the ground on the right side. And we're going to come through and we're going to put in a vertical curve. Okay? Yeah. Here's the vertical curve. So in this particular case, darn it. So here's my vertical curve. So in this particular case, we're going to have, it's going up, right? It's a positive grade, right? Grade 1 is positive or negative? Positive. Grade 2, positive or negative? Negative. So we're coming through and going like this, but this is only one option, right? I could have a vertical curve like this. So what's my G1, positive or negative? Negative. G2, positive, okay? Remember what we talked about before, that where is our stationing? Is our stationing along the road like this?
No.
No, it is only horizontal. So L, capital L represents which distance of the vertical curve?
Horizontal.
The horizontal distance. Everybody agree? That represents the horizontal distance. Okay. Here's our datum. Here's our datum. So what do they mean by capital Y? What does Y represent? The elevation, right? Because this is the elevation to the BVC. We didn't look at that acronym. Not, it's not an acronym. BVC, what do you think that stands for?
Beginning vertical curve.
Beginning of vertical curve. Or?
Vertical
Point of curvature.
point.
Right, vertical point of curvature. So just like the horizontal curves have two different initialisms for the beginning and the end, so do vertical curves. Beginning of vertical curve. What's this? End of vertical curve. Vertical point of curvature. Vertical point of tangency. So the capital Y represents the elevation because it says Y sub BBC, and it makes sense. It's the vertical distance from the datum to the beginning of vertical curve, so this is the elevation of the vertical curve, right? So if I wanted to know the elevation of this point, it would be this distance. It would be the distance from the datum to here. Or I could say it's the elevation of the BTC plus this. Everybody got that? X represents the horizontal distance to any point along here. So in this particular case, they're trying to locate this point, and it's a horizontal distance X from the beginning of vertical curve. Everything's represented from the beginning of vertical curve. Good? Okay, so what do we need to know? We need to know BBC or VBPC. We need to know EVC or VPT. We need to know what G1 is. It's the grade of the first curve line. G2 is the grade of the second curve line. We know that capital Y represents the elevation. And the only other thing we need to know is this. What do you think the V represents?
Point of intersection.
So it's the vertical point of intersection, but what do you think V stands for? Vertex. Now, what is different between the vertex in surveying and the vertex? What is the vertex of a parabola? It's the highest point on a parabola. Is the vertex here the highest point on the parabola?
No.
No,
No.
it's only, it actually is the center point, because we are only doing vertical curves where this is L over 2
Mhm.
and this is L over 2. Those are called equal tangent curves, and you'll see that wording in a little bit. There are vertical curves that are not like this, we're just looking at the easiest one. Okay? So the vertex is the point where G1 and G2 intersect. It is not the high or low point of the parabola. Everybody got that?
Yeah,
Okay.
but it is the same.
It's the center point.
In